Design Netflix. Hi everyone, we're here today for another Exponent mock interview with Andreas. All right, thanks so much for being here with us today, Andreas. Would you quickly introduce yourself to our viewers?
Yeah, I'd be happy to. Hey everyone, my name is Andreas. I'm a software engineer currently at Modern Health, which is a mental health tech startup.
Awesome. All right, so let's get right into it. So the question today is Design Netflix.
So Netflix is composed of like a lot of things common to a lot of tech platforms. Like you have users, they can find some sort of video content, in this case like movies and TV shows, and then they want to watch that content. So including those things, are we designing the high-level system to include everything from subscriptions, users, search, and videos, or would you like me to focus only on a particular part?
So let's focus on the core product for now. So that would be like the videos and the users that you described. And you can ignore other features like search or subscriptions.
Okay, awesome. So when you say users, in this case here, I'll write that down, users and videos. When you say users, do we want to worry about authentication or just users like in relation to the videos?
You specifically need to focus on the user activity data. So that's like the data that would go into their video recommendation engine. So you'll need to be able to find a way to both aggregate and process the user activity data that's on the website.
Okay, awesome. Great. And so given those things, will I need to like come up with some sort of algorithm for this recommendation engine?
Not in this case, that'll be outside of scope for this question, but I'd like you to be able to focus on how the data will be gathered and processed for those recommendations.
Okay, great. And so we have this video service, we have our recommendation engine, and for the video streaming service, I'm guessing it'll be important that we have high availability, even with a trade-off of, we can say, maybe not as great consistency, but decent consistency, because we'll want like fast, low latencies around the world. Is that correct?
Yes, that's correct. You should definitely account for that in your design.
Okay, awesome. So low latency, and and we'll also say global. Great. So now that we have all these things, for the background or for the recommendation engine, do you think we can run that as a background asynchronous job?
Yeah, that sounds great.
Okay, awesome. Oops. Okay. So building a list of requirements here. And then outside of these cases, I guess a larger question is how many, when maybe transitioning to scale, is how many users can we assume Netflix has?
Maybe about 200 million.
Okay, cool. 200 million users. And so I'd like to take us maybe based off of this number through some data storage estimations, and then we'll come to, I guess, organically to some of the architectural decisions along the way, if that sounds good to you.
Sure, perfect.
Okay, awesome. So we have a few different types of data that we're going to need. So our types of data are going to be video content, like static content tied to the video. So things like the names of the movies, descriptions, what else? Thumbnails, maybe like a cast list since we're doing movies and shows. And then we'll also need user metadata. So like when the last watched, if they have watched a show, or if when the last watch timestamp is, so we can return them to the place in the movie that they were watching. Maybe likes on a movie, like we can thumbs up or thumbs down a movie on Netflix. Then I guess the last bit that we talked about, so we have this user metadata, the video static content, the video content itself, and then these activity logs. So that, although we might actually have some overlapping user metadata, I think we can probably do all sorts of tracking events like clicks, impressions, scrolls, and we can fine tune that a little more based off of what we're trying to look to optimize for in the recommendations. But since that is probably a lot larger in scope, for now I'll keep that out of scope if that's okay with you. And if we have extra time, we can go into it.
Yeah, that makes sense.
Great. And so in terms of some of the size of some of these, we can start with given this video content. So we have 200 million users, and so how many movies and shows can we, I guess, estimate that Netflix has?
Let's say about 10,000.
Okay, great. So 10,000 videos. And then given, maybe we can estimate that like movies are on average 2 hours, and then each episode of a show is maybe 20 to 40 minutes. Can we say a video is then on average like an hour long overall?
So that would be assuming that it's about strictly half movies and half TV shows, right?
Yes. Is that all right? That's okay assumption? Okay, cool. And then given that we have that, also Netflix supports different levels of definition. So we have standard definition, high def version. Let's say maybe we can say that standard definition is 10 gigabytes an hour, and then high def is like 20 gigabytes an hour. So given that, we have this, I guess here also I'll add an hour average per show, and then, or per video, and then we have this 30 gigabytes per hour of video. Then given all of that, we can estimate around 300,000 gigabytes or 300 terabytes.
Yep.
Awesome. And so given that, this is like a lot smaller than actually a lot of other video stores, luckily, because it's not user generated content like YouTube or maybe Facebook video. So we have a ceiling on the amount of videos that are being hosted. So given that requirement or that assumption, we could probably use something like blob storage, like Amazon S3 or Google Cloud Services. And then we can just store and replicate the content there, if that sounds okay.
Yeah, so why is blob storage in particular better for this type of data?
Yeah, I guess in this case, since we're just like rather than using a RDBMS, for example, I think it makes sense to be able to put it in blob stores where if we had larger amounts of data, we could just have ever increasing blob stores, and then that would not be great for us to be able to sort through and find and index. But in this case, since we have a static, a top level amount of that, I think it is okay for us to be able to search across all of that. But also we don't want to just store it inline because they're pretty large files individually.
Mm-hmm. Okay, yeah, that makes sense.
Awesome. So great. I'll start also, as we're going through this, some of the design. So we have this blob It's got a blob store here. And then I guess we can assume we're adding this in some sort of I don't know, either from an API or like a client that we can upload the videos up into the blob store. And if that's all right, we'll just not go too deep into that, but I guess we can just assume on our side we can upload videos into our system.
Sure, okay.
Cool. And so now we have this blob store. Now we'll probably want to take a look at the static content since we have these videos stored. And so for the static content, here, I'll write it down here. Oops. Go back in. So for the video static content, okay, so we'll need to store things like we talked about, titles, descriptions, cast lists, all of those sort of things. With then that will actually be correlated with the number of videos in this case, because per video we're just storing this metadata about the video. So in that case, we can probably just store these in a standard like relational database, or I guess we could also use a document store. But in this case, I think I would go with like just something like Postgres. And then we'll probably want to add a cache to it just so that we can make reads and faster to this to the client, because it's not too much data. Does that sound okay to you?
Sure. Yes, so brief question about this. What would you be caching?
So in this case, caching the most frequently accessed like activity, or in this case for a given user, let's say they access a series a lot or like a certain show that they've been watching, we'd cache that as they go to watch it so that when they go on subsequent views, we don't have to re-render all of that.
Okay, yeah, that makes sense. So it'll make their user experience faster then.
Yes, 100%. So like that latency, I guess we were talking about, trying to increase the speed of all of these parts of the service. Cool. And then I'll put that, actually create that here. Oops, it's not what I wanted. And so we'll have the Postgres here. I'll call this the static content. And then we'll have a bunch of API services. So these API services, we can, I guess, just assume in this case that the client is, from the client, the users are making calls to the APIs. And it would be great, we'll assume, because we're creating a distributed system, like horizontal scaling, or we could just add more of these services as we go. And then also, I guess we'll have a cache just with a standard maybe write through. So as they go to make the call, we'll update the cache and then go to Postgres. Cool. Great. So we have that. And so our final type of data that we talked about was the, let's see. So we have the video static content, video content right here. And then we have video static content, and then we have finally the user metadata. So this user metadata will be all sorts of things that we talked about, like user watched, last watch time, set likes. So in this case, since the metadata is tied to the number of videos as well, that will be the lower amount, but since it's tied to both amount of videos and amount of users, but amount of users is gonna keep increasing at a higher rate than the amount of videos, or hopefully that's what we hope with our service. Since we have 200 million users in this case, that's a lot more than 10,000. We can assume based off of 200 million users that we'll have, in this case, maybe 1,000 videos watched per user per lifetime for the lifetime they're on our application. So given that, which is like about 10% of our total content we assumed earlier, and given that, and so per video, let's say we store all of this information that we're storing of these user watched, likes, and things like that per video, we're gonna say maybe is 100 bytes. If that does that all seem so far okay as far as assumptions?
Sense, yeah.
Okay, great. Then from there we have, so that puts us at 100 kilobytes and times 200 million users, which is about 20 terabytes. Great, so we have 20 terabytes of data here. But this is like so our video content is actually more than this, which is great. So that means we don't have to do anything too crazy. But since we'll need to be able to query it in this case, whereas our video content, we just needed to pull it from a store, we don't need to actually, I think, store it in an S3 bucket. I think we can go ahead with something like with Postgres in this case, since we're already using that right here in video static content. So we got Postgres, but we will need it to be highly available because we are using that, like we talked about, we want low latency. I guess we have the option of going NoSQL with something like Cassandra, but I think in this case we should do RDBMS. And if we're going to do that route, we definitely need to shard the system. I would say we could shard it based off of the user metadata, which in this case we could index it based off of user ID. I think would make sense since it's so user focused, the data. And then each shard we can say is 1 to 10 terabytes of data. And so that way we can have really quick reads and writes on the related data.
Mm-hmm. So to recap then, that means that each shard is actually assigned to a range of user IDs, right?
Yes, exactly.
Gotcha. Okay.
Great point. Yeah, not an individual user ID for each shard. That would be a lot.
Yeah. Okay, so that makes a lot of sense. Is there a particular reason why you chose to use Postgres instead of NoSQL?
Yeah, I think in this case, although it's more complex for us to set up like a sharded system, NoSQL out of the box would allow us to do a lot of this stuff. I think to be able to make complex queries on this large set of data, we'd rather, and also the background jobs we're running, we'll want to use Postgres instead of NoSQL. Is, I guess, in my opinion, the advantage of how we should use Postgres versus using NoSQL.
Right, okay, that makes sense.
Cool. All right, awesome. So now here, I'll go ahead and also add this up here. So connected also to our API services. Let's see, we have this. Oh yeah, and we can use like an in-memory cache for this, maybe like Redis or Memcached. I don't know if I mentioned that before, but we'll cache also on both of these pieces of content. So this isn't the static content, this is the user metadata. Okay, great. And this is Postgres also. Okay, awesome. And yeah, actually, I'm realizing as we're going through this, one thing I wanted to mention is since we have these horizontally distributed load balance or horizontally distributed services, we'll want a load balancer to sit in front of them to be able to distribute the load evenly between all of them.
And this would be the load from users, right? Not from internal servers. Okay.
Yes, great point. Yes. I think if we wanted to, since we'll have asynchronous jobs, I imagine that we won't need to balance load from those. But however, I could see if we are like uploading a lot of information, we might want to consider a load balancer on this side, on the backend calls to upload videos. I think that's a great point.
Okay, great. And are there any ways that we can probably improve the speed of the requests?
Yes. So I guess in this case we have this, and as I talked about this Redis cache, and I guess that's how this will come in. We'll want to make sure that because we're using this write through caching, that will have speed on both of these for the user metadata as well as the static content.
Mm-hmm. Okay, great. So that would be like for each user, you basically cache the most recent like metadata for them?
Yes, exactly. And so keeping that hopefully would increase our availability in that case.
Gotcha. Okay.
And so now that we have all this put together, there's probably one last consideration also when you're talking about speed and lowering latency is the global nature of these videos. Since we're serving them all around the world, how can we make this fast? Because right now we probably we were assuming maybe one data center, and it's like how we have users all over the world. So in this case, we can also add a CDN between our blob store over here and the end client. So I guess in this case, we can add relevant, run a job that has, let's see here, I'll call this maybe CDN populator. And I'll switch these actually. But, oops. There we go. So, and that'll connect to the CDN itself. So in this case, from the CDN, we'll serve the most relevant content to users that are around the world based off of where they're geographically located. There's probably, Bridgerton came out in the US and then a bunch of people are watching that, so we'd probably want to cache that there. And so the populator will take care of that geographic population of each of the individual CDNs based off of the geographic location.
Okay, thanks so much, Andrea. That was really great. So I think now would be a good time to debrief a little bit. What do you think went well, and what do you think you would want to improve on more in the future?
Yeah, so I definitely think it was cool walking through all of like how Netflix works. I think a lot of times we don't think about, because it's so seamless when we're using it, that or hopefully is that we don't think about like all of that goes on behind the scenes. I would say like there's a lot of calculations, so keeping my head on straight for that, I'll give myself a pat on the back for that. if I were to improve on something, I would probably say the manner in which maybe I go through all of this. I would probably actually do these rather than congruently. It felt a little jarring, even myself going through it, going back and forth between them, and instead I would summarize all the calculations and thoughts I had, and then go to the board to design it. But that would be the only improvement, I guess, or not the only improvement, but what immediately comes to mind.
Mm-hmm. Okay. Yeah, I definitely agree with a lot of those points actually. And I particularly thought that you did a really good job of considering what the user experience would be like and try to incorporate those considerations into your design. So, for example, you thought about how like the user might want really low latency and they want their videos to load really quickly. So you did a lot of caching to try and ensure that. And you also talked about how we're going to have users that are all over the world. And so, and the media might vary depending on where in the world they are. So having a globally distributed CDN helps a lot with that. And those are both really great considerations. Yeah, and you also did a fantastic job of considering trade-offs. You know, I always think that being able to analyze a system using the CAP theorem is a great way to decide like what to optimize for in the design versus what is okay to sacrifice on a little bit. And you did a fantastic job of that. Yeah, and I agree. Like sometimes it can be a little bit confusing to start out with trying to list out all of the detailed calculations, and perhaps as you're working through the higher level design, knowing how different components connect to each other can help you work out the details a little bit more. So I think it's okay to like, once you've gathered the requirements and asked all of your clarifying questions, I think it's okay to start out with like some of the higher level components if it helps you better conceptualize the idea in your head. How does that all sound?
Yeah, I completely agree. So thanks for the feedback.
Yeah, otherwise this is a really interesting interview to do with you, so well done.
Thank you.
And thanks everybody who's watching, and good luck on your upcoming interviews.